Hey, my crazies, how are you? So today's lesson, Unit 5, Topic 2, we're going to look at graphs and see if we can come up with the equation in an intercept format that the graph came from. So we're going to work backwards. We've been doing that a lot in this class. We continue to always work backwards. You are going to need your calculator, and we're going to start off right away with putting two equations in our calculator, and here they are. You might want to call this y1 and y2. So while you're getting all that ready and entering this into the calculator, which I will do along with you, I have a mysterious request for Mystery Skulls money. And I have no idea who handed this to me, but here you go.
Stop worrying about things I can't control. Stop worrying about dollars I don't know. Gotta stop worrying about things I cannot know. But sometimes it feels so good. Money don't matter if it feels for you. Money don't matter if you're hard home. Money don't matter if it feels for you. I used to worry every day. Now I got better things. Cause I'm hurrying, slow down and take control. Cause I'm worrying about your problems, you should know. Cause I'm feeling like my life is such a mess. Because the world's got me in it. It's my time and I should live it. Oh, money don't matter if it feels for you. Money don't matter if you're home. Money don't matter if it feels for you. I used to worry every day. Now I got better things.
Okay, so I hope you were able to graph those in your calculator, and I wanted to point out something really important before we begin this topic. If you notice, both graphs have the same roots. They cross the x-axis at the same exact spot, except one of them goes up really, really high and really, really low, and then the other graph kind of is a little more squished. But they have the same roots. That's important to realize. There are many, many equations or functions that can be graphed and have the same exact root, but they might be amplified, stretched. As we work backwards from a graph like this, which really is not hard to do, it's that one little gotcha that I want you to think about. It's that depending on the coefficient, or you might say your A value, might determine whether or not the graph is very tall and thin or short and squished, even though it has the same roots. So that's what we're going to look at today. This is a very nice topic. We're just working backwards, making equations, but there's just that little kind of gotcha, okay? And it's all about the y-intercept. So let's take a look at what we're talking about. Let's take a look at these two graphs individually like you have on your worksheet. So here's the first one. This was a picture from my calculator. So what do we know? Okay, the degree. 1, 2, 3. 3 roots. Third degree. What's n behavior? Well, according to this picture, it looks like that. And if you remember Miss Zanfini's worksheet from yesterday, she would say n behavior that looks like this would be positive leading coefficient, and it would be a degree that is odd. So sure enough, we have an odd degree, and n behavior that looks like this would be positive. Let me change my pen because it won't fit. Hang on. Okay. Positive coefficient. So we want to fill out this entire sheet here, and you'll see how easy it is to then make an equation. Okay, what are the roots? So the roots are here, -2, here, 1, and here, 4. X equals -2, x equals 1, x equals 4. What would that look like in factored form? Here's what we really need to know. This will help us with the equation because this is basically it. So in factored form, we would reverse the signs of our roots and we would say x plus 2, x minus 1, x minus 4. So now this is the really important part. What is the y-intercept? The y-intercept is the value of the function at x equals 0. So we're going to put in 0 into our factored form and see what should that y-intercept be. Okay, so let's go. 0 plus 2 times 0 minus 1 times 0 minus 4. That would be 2 times -1 times 4, which is 8. So what does our intercept look like from the graph? If we look up here, sure enough, I'm sorry it's a little shady right there, but it looks like 8. So if that's the case, if the y-intercept that we know should be there based on our factored form is the same as the actual picture, we don't have to make any changes. Everything is just fine. So what is the intercept form of this equation? It's right here. Okay, so let's look at the other graph, which you know had the same exact roots, but it was a little more squishy. So the next example, what is the degree? Same, 3. What's the n behavior? Same. Like this, right? So that would be a positive coefficient. Okay, so roots, same. Roots are going to be x equals -2, x equals 1, and x equals 4. So the factored form, nothing's going to change there. X plus 2, x minus 1, x minus 4. Based on this factored form, what would our y-intercept be? What would we expect it to be? So we plug in 0 for x, because that's where the y-intercept would be. So we have 0 plus 2, just like the last time. 0 minus 1 times 0 minus 4. That is 2 times -1 times -4. Okay, again, positive 8. What's the observed y-intercept? Now this is where we call shenanigans. This picture apparently is not exactly what we found here in our factored form. So something's wrong. We're using the roots, we're using the m behavior, That's all good. That's solid math. But why are we getting this? So we just have to account for that. It's not the end of the world. It's not the hardest thing, but we definitely have to account for that. So our observed y-intercept, you might want to say, is y equals 2. So now when you write the final answer, f of x equals, you've got your factored form. It's a positive coefficient, so I'm not going to write anything in front of it. X plus 2, x minus 1, x minus 4. You now have to ask yourself, how did you get from our y-intercept to the observed? Okay? How do you do that? Well, how do you go from our guy, which was 8, to what we see, which is 2? Well, you know because it was on your worksheet. You did this. You put it in your calculator. You would have to divide by 4. That's how you would go from 8 to 2. A fancy way to say divide by 4 is to multiply by 1/4. Perfect. And that's it. That's the only gotcha here. I think you'll agree that the rest of this is pretty straightforward, but it'll just be that when the picture of your y-intercept doesn't exactly match the y-intercept that you have based on your factors. So for these next two examples, I'm not giving you the equation to put in your calculator. You're just seeing the picture that came out of my calculator. So I know the answer, but you know, I'm going to help you figure this out. So let's start with the degree. What is the degree of this function? 1, 2, 3, 4. Fourth degree. What's the end behavior? Again, going back to Ms. Zanfini's worksheet. If the degree is even, like a parabola, right, with a degree of 2, if it's even and the end behavior is pointing downward like that, then you're talking about a negative coefficient. Okay? What are my roots? Again, pretty straightforward. They're here, 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 and here. So x equals -3, x equals 0, x equals 2, and x equals 4. Let's put that into factored form. Remember, change the signs of your roots. X plus 3. What happens when you have x equals 0? It's just x. X minus 2 and x minus 4. Perfect. So, does the picture of this y-intercept, which we observe to be at 0, is that the same as the y-intercept that we would get using our factored form? If so, we're basically done. If not, we have to make an adjustment, so let's take a look. Let's plug in 0 for x. 0 plus 3 times 0 times 0 minus 2 times 0 minus 4. Okay, so that's 3 times 0 times -2 times -4, which is 0. So we're happy. The observed y-intercept is our y-intercept. There's nothing to do. We do need to have a negative coefficient. That's huge. So let's write this out. F of x equals negative. And then let's do our factored form. X plus 3, x minus 2, and x minus 4. If you're wondering right now if the order matters, absolutely not. We could have done this, which I think I like because it just looks nicer to have the x first, I think. And just to show you, I'll reverse the 4 and the 2. They're both the same. Okay, so either way works. I kind of like this way better. It just looks nice. You know how I like to go to those dinner parties and don't want to be laughed out of the room? So, okay, listen, I'm going to have you try the next one. I'll stop it and finish it with you because I think there's a little bit of intercept action going on that we have to deal with. So we had this factored equation right here, but we needed to multiply the whole thing by 3 because that's how we would get from our y-intercept to the one we see on the graph. We need to be careful when we're looking at a graph to make sure that we pick the correct equation. And this is how you do it. Find your y-intercept, compare it to their y-intercept, make the adjustment that's necessary, and then you're done. I hope you liked this video. If you have any questions, please come to Extra Help. See you next time.